So, hello everyone, my name is Harjot Singh and I'm a final year master student and I'm presenting my research results for my thesis. And the topic for my thesis was like logistics optimization for circular economy, a vehicle route planning based analysis, which I have done for a company called Honkai Ukiyo-e, which was consulting a local Icelandic company for their logistics optimization for the collection of animal raw materials, and which I did under the supervision of Professor Petri Hello. And here are some of my topics which I'm covering in my presentation. Which the first I will discuss some keywords which are very important to understand my thesis. Secondly, it's the research background and context. What was the main idea or what was the main reason behind doing this thesis, and the main objectives, what I tried to fulfill in my thesis, and what method I applied to fulfill these objectives. And finally, I will discuss my results, and I will give my insights and conclusion in my final slide. To begin with, we will firstly discuss the keywords which are very imperative to my thesis. Firstly, it's the cycle time. So it's the time that one animal takes to die at a particular farm. It was calculated by the formula of 1 divided by the daily amount of carcasses. Second is the visit frequency, which denotes the days a particular farm needs to be served. This was calculated with the help of a rand between functions in the Excel. So rand between, and the next keyword is the rand between itself, which is the function in Excel used to generate a random integer between two whole numbers widely used in different scenarios. And lastly, it's the daily demand. So it's the number of animals dying daily at one particular farm. It is also the daily amount of carcasses. So these keywords are very important in my thesis, particularly the cycle time, which was very important to calculate the probabilities and sort out the routes or the stops in particular scenarios. So we go through my research background and context, so why this research was needed. So this was very crucial in response to the allegations made by the European Free Trade Association and their quote regarding Iceland not adhering to the EEA obligations, that is the European Economic Area obligations regarding the animal byproducts and their disposal. And this project was aimed at the proper disposal of animal products that fall under the risk category 1 according to the Ministry of Food, Environment, Energy and Climate in Iceland. And implementation of uniform collection system was also a main goal of this thesis, which was very imperative to prevent the mixing of materials, which was devised in consultation with GMM Finland. So here are my key research objectives. What I try to fulfill in this thesis, that is to plan a vehicle routing for animal byproduct collection in Iceland at the lowest possible cost, which was my key performance indicator also. And second is to calculate the number of trucks necessary to carry out the operations efficiently. And lastly is to compare a different locations for a potential factory setup for processing of these animal carcasses. So let us now try to understand my research method, what I applied to get my results. So the primary tool used in my logistic analysis were Open Door Logistics. It's a software which is very capable of doing vehicle advanced configuration, and it's very advantageous to use for getting a proper route or to optimize vehicle routing. The first key step was to calculate the daily demand for each farm, which was calculated by the formula shown in the figure 3.1. So quantity is equal to 2% of the number of animals dying in each farm, multiplied by the weight of the animal, and divided by 365, which is the for the whole year. So to get the daily demand, so it was divided by 365, and 2% was the assumption of that we assumed that 2% of the animals will die in each farm. And and we can see the different type of animals in Iceland, or the different type of animals in each farm and their weights in the figure 3.2. So we can see that this bovine has the weight of 425 kg, sheep 60 kilograms, horse 375 kilograms, goat is 50, and we can see the rest of them. And then we calculated the cycle time. So cycle time was calculated for each farm, which was determined by the formula 1 divided by the daily demand. So it is the amount of the time that is that is taken to for one animal to die in each farm. And then the rand between function was used to calculate the visit frequency based on the cycle time for each farm. So the rand between function was used. We can in the above cycle time in the proper intervals, and to sort out the to get the visit frequency, which can be 1 day, 2 day, or 3 days. So visit frequency means that we have to visit a particular farm in how many days, and it was calculated by using the rand between function. Furthermore, a total of 40 scenarios were listed with specific constraints to test their feasibility in ODL, which can be seen in figure 3.3, which is in the next slide. So these are all the scenarios which came out, and what we planned how to operate this all the animal collection route. So we can see that we were aiming to have a 2 day, 3 day, or even a 1 day demand, and the amount of trucks also we stimulated that how many trucks we required, the service time that is from 6 to 22, and we have also tested from 9 to 5, that is 8 hours driving. And these are some stops to be covered in each scenario. So each scenario, so yeah, we using the rand between function and the visit frequency, so we created some scenarios to have to get some optimal routes and test their feasibility in ODL, whether they are feasible or not. So the next we discuss the results. So out of all the 40 scenarios, a total of 7 scenarios were found to be feasible. That is feasibility test, how it was determined, that is we can cover the entire stops within the given time, and within the using the required number of trucks available. So the cost, time, and number of vehicles used, and the stops covered for the key performance indicators, with the cost being the most vital determinant. The performance of each feasible scenario on the above mentioned KPI can be seen in figure 3.4, which we will see in the next slide. Since the cost was the most important factor, hence the scenario 16 was selected as the most favorable solution with the 3-day demand, 6 trucks to use with an estimated cost of 796,000 euros for the entire year, which was calculated based on the cost of 2 euros per kilometer. So what does this mean is that we have to operate every 3 day, to cover the animal carcasses, and we only require 6 trucks to be used, which was estimated to be 10, but we require 6 trucks in use with an estimated cost of 796,000 euros for the whole year, based on 2 euros per kilometer. So we can see my all the possible feasible scenarios in this figure 3.4, which are all the which can be all the solutions for my problem. We can see the scenario 7, which is a 2-day demand. That means we have to serve this route every 2 day, and the vehicles used is 4 vehicles, and the distance traveled is around 3400 kilometers, and the cost was 2 euros per kilometer. So the cost for operating one time comes out to be 2 euros multiplied by the distance traveled in each scenario, which comes out to be 6,000 in case of around 6,700 euros in case of scenario 7. And we can see for all the scenarios the cost per operation. We can also see the time taken for the each operation for all the feasible scenario, which is around 13 hours max, or 13 and a half hours max. And we can also see the cost, monthly cost for all the scenarios, which we get in case of a 2-day demand we multiply it by 15, and in case of a 3-day demand we multiply it 10 to get the monthly cost for the each scenario, and then we also get the yearly cost. But since the cost was the most important factor in considering our route, so we decided to go for the scenario 16, which we have to implement every 3 day. We have to use 6 trucks, which is the distance traveled will be for around 4,800 kilometers, and the cost in euros per operation is 9,481, which is more than the cost per operation when we compare it with scenario 7. But when we see the yearly figure, we can see that scenario 16 have the lowest possible cost among all the possible scenarios. And here is the possible feasible route for the scenario 16. Here we can see that we are able to cover all the stops with 6 trucks in use. And here is also an example of an unfeasible solution, which is in case of scenario 3. And so we can also go in my previous slides where we can read about the scenario 3 constraints. So constraints were like vehicle, how many vehicles are used in that case, how many stops are to be covered, and the time and the number of vehicles available. So these were the important constraints in each scenario. And here we can see the unfeasible solution in scenario 3, where we cannot cover all the stops within the required constraints. And in order to see the what's the scenario 3 what's the in case of scenario 3, so we can go over my previous slides and we can see scenario 3 what constraints it have. And this is also another feasible solution, which is in case of scenario 8. And this is also a very feasible solution, and it's very possible because we are covering all the stops in this also. But the negative part was this, that it has the higher cost as compared to scenario 16, so it was not the favorable solutions to be implemented. So the conclusion, what were the key findings, or what were my key analysis in this thesis? That it was determined that the optimal solution would be carry out to collection operations every 3 days, which was more cost friendly than running the operations daily or even after 2 days. The required number of vehicles were found to be 6 to carry out the collection process efficiently and to cover the entire stops in case we operate in the scenario 16 constraints. And lastly, the Dusnes was selected to be the location for the factory setup due to its efficient location and the possibility of covering entire stops adequately within the time limit. So these were all my objectives, as I discussed earlier, to find out the optimal logistical solution to carry out the vehicle routing, and to determine the number of trucks that is required to cover the entire operation, and lastly to find out a possible location for a factory setup. And these are all my conclusions regarding my thesis, that what they can do, and I have been able to fulfill my objectives through my results and method applied. And thank you, and this was my research presentation results presentation, and I am open to any questions from your side. Thank you.